In this module, we are going to learn about Snort. Snort is an intrusion detection system. Intrusion detection system usually identifies the malicious behavior occurring on the system. So, there can be two types of IDSs, anomaly based and signature based. Anomaly based finds out if there is any behavioral disorder. For example, if students are trying to log into the machine at the night, at the midnight, then it would be considered as a malicious activity, because they are supposed to log in into the server during the day hours 10 to 6. Pattern based, as we have seen, it is like a virus signature where a pattern is fixed and IDS, intrusion detection system, will try to match the pattern. In the Snort, we can define a rule set which matches, and then if it is the matches with the rule, then it tells that some anomaly has occurred. To start with the Snort architecture, so packets come from the network or from the internet. There is a packet decoder, then the packets go for pre-processing. It goes to the detection engine where we have defined the rules. Packet is dropped or packet is logged and alert is made. So, in Snort there can be three activities, either alert, log or drop. Drop means no activity to be taken. In case of logging and alerting system, it has to be given to the output modules and they would put an alert or log to a file. Snort, first download the Snort, which is the installer is available on the site. If you type Snort down installer in the Google, you can easily download it. Once installed, the Snort can be identified in C drive where you are installing your program. There you try to find out the Snort directory. In that you have a bin directory. Now that in the bin directory, go and type Snort, and if you do type Snort -w, you will get all the interfaces those are available on your machine. If I try Snort -w on my machine, I can get the index, physical address, IP address, device name and description. So, physical address, IP address, so no IP address defined, so it shows all the disabled IP addresses, physical address and the device names. Once you have got all the interfaces, then you need to check on which interface you want to start the Snort. If you want to start Snort on the second interface, it is called I2. So, then type a command Snort -v -I2. So, if you try to do Snort -v -I2, it would start running in the packet dump mode. So, what does it do? It would try to read the packets. To stop, what I did, I tried Ctrl C to stop the Snort. So, it gave me a summary, how many packets received, how many analyzed, how many dropped, how many filtered, how many outstanding, how many injected. So, 77 were received, 1 was analyzed, 0 dropped and 0 filtered. It also gave me a summary that Snort ran for how many days, how many hours and how many seconds. This gives you a summary and you can find out all the statistics related to how many TCP packets, how many UDP packets, how many related to IPv4, IPv6, whether it was from Ethernet, it was from VLAN, all kind of statistics you can study through Snort. Fine. Even if you have not generated any traffic, you will find out that Snort is detecting some traffic. That happens because if you are connected to the network, after certain amount of time there is always ARP and RP request generated. For that, ARP always usually broadcasted to all the hosts on the network. That is why even if you have not initiated any network traffic, you will be continuously receiving the ARP packets, and that is why Snort is detecting some traffic on the network. Once you have tested this, then it's time to test a small thing. Type a command saying Snort -c rules.txt -a console -l. -a means console, you get the output on the console, -l you log it to the files also, -l Then we have said //log. You are right now in the bin directory. The log directory is in the parent directory of the bin directory. Who is the parent directory of bin subdirectory? Snort. So in the Snort you will have a log file where you want to log all the records. So -l //log -k and ASCII. What do we have written in the rule file? Alert TCP any SID1 MSG TCP packets. Just to give a brief idea before we go into the detail, it says alert on which protocol? TCP. The any says source IP is any, source port is any. On the right side it says destination IP is any and destination port is any. Then it says SID, that is sequence ID of the rule is 1, message that says it is a TCP packets. If you try this, you will get an output saying that how many TCP, if there is a TCP traffic going on, it would find out. So once now you have set a rule, it will say parsing which rule file, it will give the name of the rule file. Now one more thing, you need to store this rule.txt file where in the bin directory from where you are executing the snort command. Say that parsing rule file rule.txt, it says once snort rules read, 0 decoder rules, 0 preprocessor rule, 1 option chains, right. It gives you according to the rule port counts how many TCP, UDP, ICMP and IP. So since we have not generated any traffic, when I tested this it says all zeros, but you can try this command to find out what all traffic is going on. Snort rules. So now the important is what to write in the rule.txt or how a snort rule is formed. I gave you a simple example saying alert any and then we had a body part. So Snort uses a simple lightweight rules description language that is flexible and quite powerful. Lightweight means it does not consume many resources. The first is that Snort rules must be completely contained in a single line. The Snort rule parser does not know how to handle rules on multiple lines. Snort rules are divided into two logical sections, the rule header and the rule options. The rule header contains the rule's action protocol, source and destination IP addresses and net masks, and the source and destination ports information. The rule option section contains alert messages and information on which parts of the packet should be inspected and to determine if the rule action should be taken. Example rule alert TCP any. So source says any source port is any, destination is 192.168.1.0/24, port destination port is 111 and content is double quote and it is put in the vertical bar 000186A5 and message is mount DXS. The text up to the first parenthesis is called the rule header and the section enclosed in the parenthesis is rule options. The words before the colon is option keywords. So in the previous slide, content is a keyword, MSG is a keyword. The rule options sections is not specifically required by any rule. They are just used for the sake of making tighter definitions of packets to collect or alert on. All of the rules that make up should be true to indicate an action. When Snort rules when taken together means in one file if you have defined many Snort rules, they are logically ANDed, and various rules in a Snort rule library files can be considered to form a large logical OR statements. To refine what I said, if you have defined many elements saying that contents is this and other options, they are ANDed together. And if you have defined many rules in the rule file, they are ORed. So either of the rule is true, then the packets would be taken action for. Rule headers have action parts. It says 3 action parts: alert, log and pass. Alert generate an alert using the selected alert method and then logs the packet. Log logs the packet. Pass drop, ignore the packet. So, first item in the rule is the rule action. Rule action tells what to do when it finds a packet that matches the rule criteria. The protocols in the rule headers defined can be TCP, UDP and ICMP. The next portion of the rule header is the IP address. We have seen we wrote any may be used to define any address. Snort does not have any mechanism to provide host name lookup for the IP addresses. So, we need to define IP addresses, we cannot define the host name. Straight numeric IP address or CIDR block. CIDR stands for classless inter-domain routing. CIDR indicates the net mask that should be applied to the rule's address and any incoming packets they are tested against the rule. So, CIDR block mask of /24 indicates a class C network, /16 a class B network, /32 indicates a specific machine address. The address in the CIDR combination 192.168.1.0/24 would signify the block of addresses from 192.168.1.1 to 192.168.1.255. /24 suggests that 24 bits are for the network address. Address in the rule, so example is alert TCP any and destination says 192.168.1.0.24. So, destination address was set to match on the 192.168.1.0 class C network. Snort rules, you can use the negation operator. Negation operation is specified by the exclamation. The example says alert TCP not 192.168.1.0/24 any to 192.168.1.0/24 111 content is this and message is this. Rules IP address indicate any TCP packet with a source IP address not originating from the internal network that starts with 192.168.1 and the destination is an internal network that is 192.168.1.0 to 192.168.1 to 255. Port numbers may be specified in a number of ways, including any ports, static port definitions, ranges and by negation. Any ports are a wildcard value, meaning literally any port. Static ports are indicated by a single port number such as 111 for port mapper, 23 for telnet or 80 for HTTP. Port ranges are indicated with the range operator colon. The range operator may be applied in a number of ways. Log UDP any 192.168.1.024 1:1024. So, log UDP traffic coming from any port and destination ports ranging from 1 to 1024. The second rule says log TCP traffic any then we have specified the destination CID address and port is specified by :6000. So, we have not given the initial range, it says any port less than or equal to 6000. Log TCP any :1024 to the destination address and then we have specified the starting port, but we have not defined the ending range. So, it logs all the TCP traffic from privileged ports less than or equal to 1024 going to ports greater than or equal to 500. So, source port is starting from 0 to 1024 and destination is 500 greater than and greater. You can specify negation in port also. The negation operator remains the same, it's exclamation sign. So, log TCP any and the port negation is specified by 6000:6010 and we have kept a negation sign. It says that log traffic who are not destined for the ports between 6000 to 6010. Direction operator, we have seen is shown direction operator in the single direction, it shows the direction. The IP address and the port numbers on the left side of the direction operator is considered to be traffic coming from the source host, and on the right side are the destination hosts. There can be a bidirectional operator which is indicated by the less than and greater than symbol. It says that the traffic is bidirectional, usually useful in telnet or POP3 sessions. So 23 is a telnet. So log the packets which are not originating from the internal network to the internal network with a destination port of 23, and in the reverse direction also originating from the telnet through the internal network and going to the outside network. In this case we can have a bidirectional data. Rule options form the heart of Snort's intrusion detection system. There are certain keywords, 15 rule options which are given by the colon. Rule options are MSG that prints a message in alerts and packet logs, log2 that says log the packets to a user specified file name instead of the standard output file. Minfrag says set a threshold value for the smallest acceptable IP fragment size. TTL says test the IP headers TTL field value. ID says test the IP headers fragment ID value for a specific value. D size test the packet's payload size against a value. Content search for a pattern in the packet's payload offset. Modifier for the content option. Depth is a modifier for the content option, sets the maximum search depth for a pattern match attempt. Flags test the TCP flags for certain values. Sequence test the TCP sequence number field for a specific value. ACK test the acknowledgement field for a specific value. I type and I code, they are related to ICMP type and ICMP code. So if ICMP type is 1, there are certain ICMP codes related to it. For example, ICMP type 1 is could not deliver the message host unreachable. Host unreachable can be because of various reasons. Either the host is down, host is up but not listening, or the network is down, or some other reason. So for that, code is attached to the type so that we can identify for which reason the host unreachable error comes. I type and I code, they are related to ICMP type field. They can also be incorporated into the Snort rule. And session, it dumps the application layer information for a given session. How to use message, that we have already seen in the previous rules. There is a simple text string that utilizes the escape character. So you need to put your strings which need to be exactly matched, should be kept within the double quotes, and if you are using more keywords, they all should be separated by the semicolon. Log2 option, we have already seen in the list, it stores the log into the specified file name. How to specify the file name? Within the double quote. Minfrag sets a minimum size threshold for a fragmented packet. It sets the boundary for the minimum fragmentation size that is acceptable on a network segment. Why this is helpful? Because if attacker fragments the packet in the small tiny pieces and transmit it to use the bandwidth, then this can identify that minimum fragment size should be this, tiny pieces are not acceptable. So there is virtually no commercial network equipment available that generates fragments smaller than 256 bytes. So what happens, people can take advantage of this fact by setting their min fragment value somewhere below that threshold. How to use min fragment? You can specify min fragment to be 256 and message would be tiny fragments detected, possible hostile activity. TTL option can be set by a number. If you have option keyword is used to test for an exact match in the IP header fragment ID. For example, the value 31337 is very popular with some hackers. They set the IP header ID field to 31337. So we can define a Snort rule saying that if the ID is 31337, then the packet should be alerted. D-size option says to test the packet payload size, it may be set to any value plus use the greater than or less than sign to indicate the ranges and limit. Content keyword is, we have seen that content can be enclosed within the pipe. The characters which are to be exactly matched should be written as it is. They are represented as a byte code. Byte code represents the binary data as hexadecimal numbers, and they are the good shorthand for the describing complex binary data. Now, when the packet comes, it has to be matched for the content. So, pattern matching is to be done. There are certain pattern matching algorithms, but Snort uses Boyer-Murray pattern matching algorithm. Example of the content: alert TCP any. So, this is the destination IP address, destination port, and content to be matched is within the pipe, which is the binary hexadecimal code of that binary value, and then if you want to exactly match to bin sh, they are written as it is. So, hexadecimal code need to be kept between the pipes, and ASCII characters need to be kept within the double quotes, and then the message can be printed. Offset rule says that from where you need to start looking for a search. It modifies the starting search position for the pattern match functions from the beginning of the packet payload. Usually the search begins from the packet payload. For example, CGI scan detection rules where the content search string is never found in the first 4 bytes. So, we can set offset to be 4, so search should always begin after the 4th byte. Depth says it is also related to content rule option. Depth says the content pattern match function should search for the pattern from the beginning to up to what bytes. So, it is useful for limiting the pattern match function from performing inefficient searches once the possible search region has been exceeded. The example is, if we want to find out a certain pattern and we are sure that it is in the first 20 bytes, then there is no point in going beyond that. So, we can specify depth to be 20. For example, alert TCP any destination port, content is CGI bin, offset is 3, that means start search from the 3rd byte and go up to the 22nd byte. There are 8 flags associated with TCP: fin, sin, RST, push, ACK, URG, to reserved bit 2, reserved bit 1. These flags also can be checked through the Snort rule. Example is alert any, the direction sign, destination is specified by 192.168.1.0/24, destination destined for any port, but flags set are S and F. So, S is related to sin and F is related to fin. So, if sin and fin flags are set, then this rule will possibly send an alert. How to specify the sequence number? TCP always uses the sequence number so that it can keep track of the packets being sent and acknowledgement being received. So, we need to say sequence number. We can specify it through the keyword SEQ, sequence. Acknowledgement rule option keyword refers to the TCP headers acknowledgement field. If nmap is used for TCP ping, sets this field to 0 and sends a packet with TCP ACK flag set to determine if the network host is active. In that case, we can check if the ACK is 0, then it is a TCP ping. So, how to write a Snort rule? So, alert any, specify the destination IP, destination port, flag set are A, ACK is 0. So, we need to check if the ACK set is 0, then message is nmap TCP ping. Then I explained you ICMP has I type and I code. So, if you want to check ICMP type, then you can use I type. Sometimes ICMP type values are used to identify the denial of service and flooding attacks. I code is just in context to I type. You can always set the I code value. Out of range values can also be set to detect the suspicious traffic. So, I code rule option keyword is identical to I type rules and it sets the numerical value here. Session keyword, and there are certain advanced rule options also. But this module gives you a brief idea about the basic options that you can use in Snort. So, to summarize this module, I started with a Snort, its architecture. So, the basic need is to do the pre-processing to identify that which type of packet is this. Then I taught you what are the rule header and